Let's take a look at the solutions to the equations you were presented with in video 1. The equations were A, negative 3x plus 4 equals 13, B, 5 equals 2/3 y subtract 4, C, 2 times 2x plus 2 equals 6x plus 6. You had to solve these equations by isolating the variable, and you had to verify your solutions. So to solve the equation given to us in question A, negative 3x plus 4 equals 13, we need to isolate the variable x. We'll do this by performing inverse operations. We're going to use the acronym PEDMAS as a guide, and you've probably seen this in earlier grades, knowing that it stands for parentheses, exponents, division and multiplication, addition and subtraction. When you're solving an equation, the first thing you're going to ask yourself is, are there any like terms that can be combined? In this equation, there are no like terms that can be combined. Negative 3x cannot combine with 4, and on the right-hand side of the equation, 13 is the only term. So when we're using PEDMAS to solve an equation, we really are using it in reverse. We have to take a look at adding and subtracting first in an equation. So we have a plus 4 that we have to make 0 with. To make 0 with plus 4, we have to subtract 4. And remember, an equation is kind of like a balance. Anything that we do to one side of an equation, or the left side of an equal sign, we must also do to the right side. To make 0 with positive 4, we need a negative 4 or a subtract 4. Negative 3x plus 4 subtract 4 is equal to 13, and we must also do the same to the right, subtract 4. We now have 0 with the positive 4. We're left with negative 3x being equal to 9. Here we have a multiplication. The inverse operation of multiplication is division. So we're going to divide by negative 3. And if we do that to the left, we must also do it to the right side of our equation. This gives us x is equal to negative 3. To ensure that our solution is correct, we can verify. So to verify our answer of x equals negative 3, we're going to substitute that negative 3 in here for x. Negative 3 times negative 3 plus 4 should be equal to 13. Negative 3 times negative 3 is 9, plus 4 equals 13. 13 equals 13. We know that the solution of x equals negative 3 is correct. To solve the equation in question B, 5 equals 2/3 y subtract 4, we need to isolate the variable y by performing inverse operations. So we're going to start by taking a look at that subtract 4. To make 0 with the negative 4, we need to add 4. And if we add 4 to the right side of the equation, we have to add 4 to the left side as well. 5 plus 4 is equal to 2/3 y subtract 4 plus 4. That gives us 9 is equal to 2/3 y. Now we have to deal with the fraction that's being multiplied by y. If we want to have 1y, we have to multiply by the reciprocal. The reciprocal of 2/3 is 3/2. 3/2 times 2/3 makes 6/6, which is the same as 1. So we have 1y. If we multiplied the 2/3 by 3/2, then we have to multiply the 9 by 3 over 2 as well. Keep in mind that multiplying a fraction by a whole number, that 9 is the same as 9 over 1. 3 times 9 is 27, and 2 times 1 is 2. We can reduce this. 27 divided by 2 is 13.5. So 13.5 is equal to y. It's okay to have your variable on the right-hand side of your equation. We can verify our solution by substituting that into our equation to check and see if our answer is correct. So to verify our solution of 13.5 is equal to y, we're going to substitute that value in for y to verify and see if our solution is correct. 5 is equal to 2/3 times 13.5 subtract 4. If 13.5 is the value of y, then both sides of this equation should be equal. So let's take a look at the right-hand side of the equation. 2/3 is difficult to multiply by 13.5 as we have it now. Let's convert it to a decimal. 2/3 as a decimal, we know, is 0.6 repeating. If we multiply 0.6 repeating by 13.5 and subtract 4, let's see what we get. 0.6 repeating multiplied by 13.5 actually gives us 8.9 repeating. Subtract 4. This is pretty close to 9. Subtract 4. 5 is equal to 9 subtract 4 is 5. 5 equals 5. We know that our solution of 13.5 equals y is correct. To solve the equation in question C, 2 times 2x plus 2 equals 6x plus 6, we need to start by simplifying the equation. We can do this by using the distributive property. 2 times 2x is 4x. 2 times 2 is 4. This is going to equal 6x plus 6. Now we need to focus on that 4 here. To make 0 with a positive 4, we need a negative 4. So we're going to subtract 4 from both sides of the equation. 4x plus 4 subtract 4 is equal to 6x plus 6 subtract 4. We're left with 4x being equal to 6x plus 2. Now, we have x's on both sides of the equation. If we want our solution to be x equal to some number, we need to get an x on one side of the equation. Let's get rid of the 6x on the right-hand side. 6x subtract 6x will make 0x's on the right-hand side. If we subtract 6x from the right side, we have to subtract 6x from the left as well. 4x subtract 6x is equal to 6x subtract 6x plus 2. We're left with a negative 2x being equal to 2. This here is the multiplication. Negative 2 is being multiplied by x. The inverse operation of multiplying is dividing. If we divide by negative 2, that leaves us with 1x. If we divide the left by negative 2, we have to divide the right by negative 2 as well. X is going to be equal to 2 divided by a negative 2 is a negative 1. If we verify our solution, we can ensure that our x equal to negative 1 is correct. To verify our solution of x equals negative 1, we need to substitute that negative 1 into the equation wherever we see an x. If both sides of the equation are equal, then we know that our solution of x equals negative 1 was correct. So let's substitute that negative 1 in for x. We have 2 times 2 times negative 1 plus 2 is equal to 6 times negative 1 plus 6. So let's start with the left side. Think of PEDMAS. That's the order of operations. It tells us what operations we have to perform first in order to get this correct. We have to do our multiplication in the brackets first. 2 times a negative 2 is a negative 2. Then we can do the addition in the brackets next. A negative 2 plus a 2 makes 0. And 0 times 2 is 0. Let's take a look on the right-hand side. 6 times negative 1 is a negative 6, plus a 6 also equals 0. We know that our solution of x equals negative 1 was correct.